To find the derivative of f of x equals x to the third minus 3x squared plus 4 all over x squared, although it is a quotient, it does not require the quotient rule to differentiate. When differentiating a quotient, the quotient rule is not always the best approach. In general, if a quotient only has one term in the denominator, as is the case in this function, and the denominator does not include a trig function, it is usually best to avoid using the quotient rule. In this video, we will discuss when you should and should not use the quotient rule at about the 1 minute mark, and then we will actually find the derivative of f of x equals x to the third minus 3x squared plus 4 all over x squared without the use of the quotient rule. We'll do that at about the 3 minute mark. Let's begin. Let's look at some examples of functions for which you should use the quotient rule, and some for which it would be better to not use the quotient rule. In general, when a function has multiple terms in the numerator and denominator, as is the case here and here, it is best to use the quotient rule to find the derivative. However, when a function's denominator is constant, it is much easier to find the derivative after rewriting this in its equivalent form, 1/7 times the quantity of 2x to the 5th plus x squared. The derivative of this function does not require the quotient rule. Additionally, when the numerator and denominator are both one term, as in f of x equals negative 8x to the 4th over 5x to the 9th, the function can be reduced using the laws of exponents to negative 8/5 times x to the negative 5th power. This can then be differentiated in one step using the power rule. When the function's denominator is one term, but that one term is a trig function, the quotient rule should be used. And when the numerator is one term, but the denominator has multiple terms, it is also best to use the quotient rule. On the other hand, the reciprocal of that function has multiple terms in the numerator, but only one term in the denominator. This is best differentiated without the quotient rule. We will shortly discuss how to find this derivative without using the quotient rule. Again, to summarize, in general, if a quotient has only one term in the denominator, and the denominator does not include a trig function, it is best to avoid the quotient rule. Realize that you can certainly use the quotient rule to find the derivative of any fraction. In some cases, you will find it easier, and more importantly, have less chance of making a mistake if you do not use the quotient rule. So, as discussed, the function f of x equals x cubed minus 3x squared plus 4 all over x squared would be easier to differentiate without using the quotient rule. Since we will not be using the quotient rule, the first step is to rewrite the function without a fraction bar. This adds a little bit of work at the start of the problem, but after doing so, finding the derivative will be much easier. One way to rewrite the function is to break apart the numerator into 3 individual terms, each having a denominator of x squared, which was the original function's denominator. Then each term can be reduced individually. The first term reduces to x to the 1st power. The second term has an identical factor of x squared in both the numerator and denominator. These factors cancel, divide away to be 1, and the second term becomes simply minus 3. The third term cannot be reduced, but instead of writing the x squared factor in the denominator, write it as x to the negative 2 power. This will make it easier to differentiate in the next step. At this point, f of x is written in an equivalent form whose derivative will not require the quotient rule. Another way to find this same equivalent form would be to rewrite the x squared factor from the denominator in the numerator as x to the negative 2 power, and then distribute it to all 3 terms that started in the numerator. When distributing, you are multiplying, and when multiplying the same base, you add the exponents. After adding these exponents, you can see that you will arrive at the same function we did earlier. Now that we have rewritten the original function in a non-fraction form, in step 2, we will differentiate without the quotient rule. In step 2, we'll actually differentiate the function. To find the derivative of f of x at this point, we can take the derivative of each term individually. The derivative of x is 1. The derivative of negative 3, a constant, is 0. And to find the derivative of 4x to the negative 2 power, the power rule will be used. To find the derivative with the power rule, you'll take negative 2 times the coefficient 4 and then reduce the power of negative 2 by 1 to negative 3. Simplifying, I will not include the factor of minus 0. The product of negative 2 and 4 is 8, and x to the negative third will be written in the denominator. We've now found the derivative of the original function to be 1 minus 8 over x to the third. If necessary, based on the context of a problem or the directions given by your teacher or in a textbook, this could be simplified into one term. Because there are two terms, to combine them, you would have to find a common denominator. The common denominator between 1 and 8 over x to the third is, well, x to the third. Rewriting 1 with a denominator of x to the third is x to the third over x to the third. And once the denominators are identical, we can rewrite this as a single fraction having x to the third as the denominator, and the numerator becomes x to the third minus 8. The simplified version of the derivative of f of x is x to the third minus 8 all over x to the third.